now at how we can form and solve linear equations. So you've looked at the solving of equations. What we need to do now is add the forming, how we form them from a word problem. So a couple of important bits of information here. The first thing you need to do is define your variable. And often you can use the first letter of the word you're trying to find. So if I want to find the number of apples on a tree, then I might say A is equal to the number of apples on the tree. If I was wanting to find the number of potatoes planted in my field, then I would say P equals the number of potatoes in the field. If we've got to find several values, we often want to find the smallest one, and we'll explain this kind of bit as we go. And thirdly, it's often quite useful to draw a diagram. So if you're not sure where to start, take what information you have, draw yourself a diagram of what the situation is. What we've got now here is a whole bunch of words that we want to look for. So when we're looking at word problems, these are some of the words you want to look for because they tell us whether we need to add, subtract, multiply or divide. So for example, total, that's a really important one that comes up quite often. If we want to talk about being decreased by or smaller than, if we want to talk about shared between, increased by. So there's a bunch of words there that you need to know what these words are and that they represent add, subtract, multiply or divide. So let's have a look at this one example here now. Now often when I would do example I would go through and I would be highlighting the numbers. Any numbers I want to highlight to make them stand out how my brain processes it. In this particular one I'm actually going to do a separate summary. I'll come back to that. So 9 people go to the zoo. Adult tickets cost $25, so there's another one I'm going to highlight. And children's tickets cost $12. Highlight the 12. The total cost was $147. So we want the number, but I'm just going to go back here. The total cost, that's giving us a hint. Our total cost, the word total is another word for adding. Then we want to write an equation and find the number of adults and the number of children who went to the zoo. Okay, so let me just move that over. Let's have a go at this one. So the information I've got, 9 people went to the zoo. Okay, then I was told that the adult tickets cost $25 each. The children's tickets cost $12 each. And in total, the total cost for all of these 9 people to go was $147. Okay, so that's the information that I've got there. Now I want to think about what I'm trying to find. And the question asked, it said find the number of adults. Just go back. It said find the number of adults and children who went to the zoo. So that's what we're trying to find, is the number of adults and the number of children. So let's define ourselves a variable, and let's say A is going to be equal to the number of adults who went to the zoo. Okay, now we need to come up with an expression for how many children went. So say I said to you that there were 4 adults who went to the zoo, and in total there were 9 people that went to the zoo. How many children would that have been then? Well, if there's 4 adults, total is 9. 9 take away the 4 leaves us with 5 children, or 4 plus 5 is equal to 9. So if I knew the total number, which is 9, and I subtract the number of adults, then that's going to tell me the number of children that went to the zoo. So this is now an expression we can use. So instead of having a second variable, C equals the number of children, we can say, well, 9 take away A is equal to the number of children who went to the zoo. Okay, so that gives us some things to work with, some variables now. Okay, we've dealt with that first bit. We've dealt with the 9 people going to the zoo, and we've defined what our variables are. Now we need to create an equation, because then once we've created it, we can solve it. So all this information here is all about the cost. So I need to put that all together into a single equation. So it tells me that it costs $25 for one adult to go to the zoo. So if there were 2 adults, then I'd be doing 2 times 25. If there were 3 adults, I'd be doing 3 times 25. So if we take the $25 and multiply that by the number of adults going, then that tells us how much all the adult tickets together are going to cost. Then we've got to think about the cost of the children's tickets. And remember, it said in total, the total cost is equal to $147. So now I've got to think, okay, well, how much did each children's ticket cost? And each children's ticket cost $12. So it's going to be $12 times the number of children. And we've got this expression for a number of children is 9 take away the number of adults is how many children we have. Now we've got an equation, so now we can go through and solve this. So I've got some brackets here, so we want to multiply that 12 by both the pieces inside it. So we're going to have 25a plus, now 12 times 9 is 108. Take away 12 times a is equal to 147. Now we want to have all, in order to solve, we want all the variables on one side and all the numbers on the other. So the 25a will stay there, the 108 is a number, so that's got to go to the other side. The 12a is a letter, so that's going to stay, and the 147 is already on the right side. Okay, so let's combine this together. 25 lots of a, take away 12 lots of a, leaves me with 13 lots of a, is equal to 147. Now this 108 here, when I move it across, it's gone from being a positive, it'll become a minus 108. So that means if I simplify 147 take away 108, that's going to give me 39. Now what I want to do is just get the a by itself. So this is 13 times a. The opposite of times is divide. So let's divide both sides by 13. That cancels the 13 on that side to leave me with a equals, now 39 divided by 13 is 3. Okay, so we've solved it. But now we need to communicate our thinking. We need to communicate what our solution is. So let's go back to our variables. We talked about a was the number of adults who went to the zoo. So if a is equal to 3, what does that mean? It means that 3 adults went to the zoo. And if there are 3 adults, then how many children went to the zoo? So 9 take away a, which is 9 take away 3. So 9 take away 3 is 6. So 6 children went to the zoo. Okay, and that is now a proper solution. So we started off by getting out the key information. Okay, we then decided to form a variable, define a variable, and we defined the other one based on that. Then we wrote an equation with the help of the words there, those keywords like total telling us that we needed to add it together. And then we just go through the procedure of solving it using those skills we've learnt before and coming up, writing down our solution. Okay, so that was example number 1. Now let's have a look at a second example. So example number 2. So what have we got here? So it talks about Isabel is 14 years old and she was born when her mum was 26. When will her mum be double Isabel's age? You've got to write an equation and use it to solve. So we're going to highlight the information. Isabel is 14. When she was born, her mum was 26. And we want to know when will her mum be double Isabel's age. Okay, so let's just quickly summarise that information. So we know Isabel, at the moment, is 14 years old. When she was born, so at birth, her mum was 26. And we want to know when will her mum be double, so 2 times, Isabel's age. Okay, So let's think about that. So, at the moment, Isabel is 14 years old. Okay, so at the moment, so if I think about now, right now, Isabel is 14 years old. So when Isabel was born, her mum was 26. So how old would that make her mum now? 26 plus the 14, it means now she'll be 40 years old. Okay, so right at the moment, Isabel is 14 years old and her mum is 40 years old. Okay. So that's what we want to start with. So that's her current age. Now we want to think, okay, well, if I take Isabel's age at the moment and add some number of years, and I'm going to call that Y, and we'll come back to defining that in a second. If I take those 14 years plus some amount, and I talk about her mum's 40 years plus some amount, then I want to find out, because I'm adding, when will her mum be twice the age, so I'm going to add on some number of years to both of them, and find out when one is double of the other. So I'm going to find out when this is double this. Okay, so let's define Y. So Y is going to be the number of years until mum is double Isabel's age. Okay. So, I want to find out when mum's age, so this is a mum's age, and this is Isabel's age, and I want to know when is her mum 2 times Isabel's age. So I need to find out when is 2 times Isabel's age equal to her mum's age. So there's our equation that we're now going to go and solve. So we're going to say 2 times 14 plus y is equal to 40 plus y. So we need to expand this out now. So 2 times the 14 and 2 times the y. So 2 times 14 is 28 plus 2y is equal to 40 plus y. Now we want all the variables on the left and numbers on the right. So this variable is going to stay. This number needs to go across. 40 is already where it should be. The y is not, so we're going to move that to the other side. So as I said, this 2y stays here. This plus y changes from being a plus y, moves across and becomes minus y. The 40 is already on the right hand side, so I leave that alone. And the 28 is moving across, so I'm going to subtract 28, because remember that's a positive 28, and when I move it across it becomes a minus. Now we can do some simplifying. 2 lots of y take away 1 lot of y, so 2y minus y gives me a y, and 40 take away 28 is 12. Now what does that mean? Okay, we've got to think about what does this mean. Well, it means that, remember our y, it's the number of years until mum is double Isabel's age. So that's saying in 12 years' time, Isabel will be, or her mum will be double Isabel's age. So that's what we want to write up a sentence. So in 12 years' time, Isabel's mum will be double Isabel's age. So how old would that be? So remember we went back to here and we said Isabel's age was 14 plus y. So if we do 14 plus 12, so 14 plus 12, that means Isabel would be 26 years old. Okay, so in 12 years' time, Isabel will be 26 years old. And how old would her mum be? So her mum is 40 plus y, so 40 plus 12, which is 52. So that means her mum will be 52 years old. And we can see then 26 times 2 is 52. So that's when her mum is double her age. So in 12 years' time, Isabel will be 26 years old. Her mum will be 52, which is double Isabel's age. Okay. now we want to do, so that was example number 2. Now let's have a look at example number 3. So this example number 3 here talks about one side of our triangle is 5 centimetres shorter than the base. So that's our first thing that we're going to do, is we're going to draw this. So we're going to draw a triangle. And it says one side is 5 centimetres shorter than the base. So I'm going to talk about, first of all, B is the length of the base of the triangle. So I'm going to call this one here, the side there, I'm going to call that B. And it tells me that one side is 5 centimetres shorter. So shorter means subtract. So I'm going to do the length of the base, take away 5 centimetres. Okay. Then the next piece of information, it says the other side is 1 centimetre shorter than the base. So I'm going to take the other side, which is 1 centimetre shorter. So shorter, I'm subtracting, so take away 1 centimetre on that side. Okay. Then it asks us and tells us that the perimeter of the triangle is 39 centimetres. And we want to find this equation. Okay, so I'm just going to write this down as our perimeter equals 39 centimetres. Okay, now what is a perimeter? Okay, so a perimeter is when we took the length of one side plus the length of another side plus the length of the third side. If we add the length of those sides together, then that is your perimeter, the distance around the outside of a shape. So in this case, it would be the length of this side plus the length of this side plus the length of that side, and that's going to add up to this perimeter of 39. So I can say B take away 1, that side, plus the next side, B take away 5, plus the third side, that adds up to give me 39, a perimeter of 39 centimetres. Okay, now we have an equation. So let's solve this. So I can actually drop the brackets from here because there's nothing on the outside to multiply by, and same with there. B take away 1 plus B take away 5 plus B equals 39. B plus B plus B. So 1B plus 1B plus 1B, that's going to give me 3 B's. Minus 1 minus 5 is going to give me minus 6 is equal to 39. And now this minus 6 needs to go across the other side. So 3B is equal to 39 plus 6, goes from minus to a plus. So 3B is equal to 45. Now I need to get rid of this 3, so I'm going to divide both sides by 3. That cancels to leave me B equals 45 over 3, which is 15 centimetres. Now we've got to think about, well, what does that mean? B is equal to 15 centimetres. So let's go back to our definition. B is the length of the base of the triangle. So we're talking about this length of the base here of the triangle. That length there is 15 centimetres. Now let's go and check what the question asked us to. Write an equation and use it to calculate the dimensions of the triangle. So we've done that, we've used it to calculate, but now we've got to find the dimensions of the triangle. So that means we want to know how long each of these 3 sides are. I know that this side is 15. I now need to work out this side. So B minus 5, 15 take away 5, that means that side is 10 centimetres long. This centimetre is one side longer than the base, so that's going to be 15 take away 1, which is 14 centimetres. So now we're going to write a sentence talking about the dimensions are, the base is 15, one side is 10 centimetres and the other side is 14 centimetres. And that is the answer to the question. So the base of the triangle is 15 centimetres and the length of the other 2 sides are 14 centimetres and 10 centimetres. And now we've answered the question.